Hey guys, it's Chili here. Welcome back to Intermediate C++ Tutorial 12. Today I'm going to be showing you how to animate your sprites and how to create a basic walking character. Let's get started. Alright, we're going to be starting again with the sprite repo. And what we're going to do is we're going to break this problem down into two classes. One class is going to be the character class, and that is going to be responsible for the positioning and the movement of the character in the world. The other class is going to be the animation class, and it is going to be responsible for a sequence of frames of a particular animation of the character. So a character is going to have, a number of animations. The Marl character will have 4 animations walking up, down, left, and right. So we'll start things off by creating a header for animation, creating a class, including some stuff. Let's get down to business. Let's get our privates in order. So first things first, if you've got an animation, it's going to have a surface where the images, the frames are stored. Now we could embed a surface object in each animation, but think about it. A single sprite sheet is going to contain multiple animations. So if you embed a surface in each animation, every animation is going to have its own copy of the sprite sheet, and that's wasting a lot of space. So instead what we're going to do is we're going to give each animation a reference to the surface, to the sprite sheet, and we'll only load one sprite sheet, and each of the animation objects is going to have its own reference to the single instance. Now the next thing animation is going to have to do is to keep track of the frames of the animation, which means rect_i. So we need a list of rect_i's. So we break out our old friend vector rect_i, and we'll call this one frames. Now, as time passes, we're going to be sequencing through these frames, and we need a way of keeping track of what the current frame is in the sequence. So we can go int I cur frame, and that will be set initially to 0. We also need to keep track of, we need to set the hold time for animations, how long any given frame is displayed before we advance to the next one. So that's hold time. And we also want to float to keep track of how long we have been displaying the current frame. So current frame time, and that will be initially 0.0. If we're drawing our sprite with a chroma key, we're going to want to keep track of that. So color chroma. Now on the public interface side, we're going to want a function to advance the frame. Actually, this advance function can be private because the outside world isn't going to be advancing the frames manually. The outside world we'll call void update with a delta time, and the animation is going to use that delta time to figure out if it needs to advance itself or not. The other thing we're obviously going to need is a draw function. Draw is going to pass in a constant v2, that is the position at which to draw, and is going to be passing in a graphics gfx. Function can obviously be const, and let's create a second version of draw. And the second version is going to also take a clip region if you want to clip to a region other than the whole screen. Now let's go ahead and implement these guys. Start from the top, draw. Alright, so graphics dot draw sprite. We want the version that takes chroma. We do not want this version. We want the version that takes a source rectangle. So we pass in pos.x, pos.y. Our source rectangle is going to be selected from frames, and we're going to use I current frame to choose it. Next, we want our surface, which is sprite, and we want our chroma color, chroma. And that should be it. The second version is basically the same, only we also want to pass in a clipping region. So this will allow us to select clipping regions other than the entire screen. Now update, very simple. If current frame time plus and equals dt. So we add dt to the current frame time. Now if that is greater than the hold time, then that means that it is time to advance the frame. So we call advance, and we do current frame time minus and equals hold time. So we consume a unit of hold time and advance the frame. Now, if dt was very long, we might have multiple frames pass. So we want to do a while loop, keep consuming time until current frame time is less than hold time. And the advance is very simple. We're just looping through animation. So we're going to do if ++ I current frame is greater than or equal to frames.size. So if we exceed the maximum index, wrap around to the first index again. Now the final thing we need is the actual animation constructor. So how is this going to work? Well, we're going to keep it simple here. We're going to assume that the animation sequences are all laid out like this, left to right in a regular grid array. So to figure out the rectangles, all you got to know is the start point, the dimensions of each frame, and the number of frames, and then you can figure that shit out. So we got int x and int y for the starting point of the sequence in the sprite sheet. We also need the dimensions, width and height. We also need the number of frames, the count, and we also need reference to the sprite itself. Now we want the hold time, and we also want to give the option of specifying the chroma key, and we'll just allow that default to magenta because it is a garbage color, and so we don't want to use it for our sprites. Use it for our chroma key. No one wants magenta. It's a terrible color. So implement that in the CPP file. It's getting a little long in the tooth. Multiply that, return that over, new line, whatever you want to call it. Now we got to initialize some stuff. We can initialize what? Well, we can initialize definitely the sprite. We have to initialize it here. We can also initialize the hold time and the chroma. And now we want to just loop count times and generate those rectangles. So we're going to use I as our index variable, and we're going to go frames.emplaceback. That'll be calling the constructor of rect I. So we got to pass it left, right, top, bottom. Left is going to be x plus I times width. So first time it's just going to be x, right? I times 0, and then I times 1, I times 2. The right is going to be x plus I plus 1 times width, right? Now y is very simple. Top is y, bottom is y plus height. That doesn't change because we're scanning from left to right. And there you go. This should be our rectangles for our frames. Now we can go into game.h and we can include animation. We also want to have a timer so that we can, update our animation with proper time. And Chilean can be writing that shit from scratch when he's got a good one, a perfectly good one right here in Fartanoid. So we're gonna copy that shit from Fartanoid, paste it into here, move it into the project, and we can now include it. So we're gonna have frame timer ft, and create the surface, and then we're gonna create the animation. Animation, we'll call this Marl right is equal to animation. X is 0, Y is 0. The width is 32, the height is 48, it's right there in the name. The count is 4 frames, the sprite is surf. The hold time is going to be 0.1 seconds. The chroma, we'll leave that as magenta. Now in game.cpp, we're going to update the animation with the delta time from the frame timer. Then in compose frame, we are going to call ModelWrite draw, and we got to give that guy a v2 position. So get pause X, get pause Y from the mouse, and the graphics is GFX. And that should be all she wrote. So now we should have an animated sprite follow our cursor. Well, 2 out of 3 ain't bad. We got a sprite, it is following our cursor. It is decidedly not animated. Alright, the problem is right here. There's actually 2 problems. Problem number 1 is the reason why our animation isn't moving is because this is not working the way we would want it to work. We would want it to do the addition here and then do the comparison. But this assignment type operators, they want to evaluate the right hand side first, and then after that perform the assignment and addition. So what it does is it evaluates this. This will evaluate generally to false, which will convert to 0, and we'll be adding 0 to the current frame time. That's not good. That's problem number 1. Problem number 2 is even if this worked the way we wanted to, for example, even if we were to do this, it still would be a bad scene because this is a loop, right? What if we keep looping? We're going to keep adding dt to current frame time. We're going to have an infinite loop here. We only want to add it once. So the proper way to solve this problem is we do current frame time plus and equal dt outside of this expression, and then in here we just compare current frame time to hold time, and we will subtract as many times as we can. Now if we build that and run it, we see now we're getting animation, but Marl is spazzing out here. And this is for a number of reasons, mainly because this sprite sheet is actually garbage. There's only 4 frames in the animation and 2 of them are duplicates. So it's not a good sprite sheet. I mean, we can test things out. We can try a different row of the sprite sheet. We can maybe turn down the speed a little bit, increase the hold time, and we'll get something like this. Now we got the walking to the left animation. It's there, but it's not pretty. So let's get a nicer sprite here. So we got this sprite sheet here, Pilgrim. It's got 8 animations. Why did I have a 0 here? That should be an 8. 8 animations, and it's also a larger sprite. Let's see what this one looks like. Now this is more like it. We can get behind this. This is some fucking sweet running animation right here. I could watch this all day with one hand on my mouse and my other hand on my hey. All right, let's move on to the character. First things first, we need to give our character a position. So position is generally going to be floating point values. We only have a v2. We want a vec2. So let's copy that stuff again from Fardenoid. So we take our vec2 from Fardenoid, we drag it over here into engine, and then we drag this over here. Now we got vec2. Include that shit and we are ready to go. We want a vec2 position and we want a vec2 velocity. Now we're going to want a vector again to store the different animations that we are going to have for our character. So animations. Now I want to give names to all the different animation sequences, and I'm going to do so by basically using enumeration. So enum class sequences. I'm going to make this private because the outside world is not going to know about this stuff. You'll see how it goes in a second. So we got walking up, down, left, right, and then we're going to want to have standing up, down, left, right. And at the very end, we're going to have an enumeration value of count that allows us to count the total number of enumerations. Now for the public interface of our character, we're going to have a function, obviously, update, right? Update the position of the character and the animation. So it's going to be float dt. We're also going to have one that allows us to set the movement direction. So that's going to be void set direction. And it's going to take a constant vec2 reference to dir direction. We're going to have a draw, pass it in graphics. That should be const actually. I just remembered this guy is going to need a surface. So we're going to make the character own the sprite surface. Finally, we're going to have the character. It's kind of a constructor. We'll just allow it to set its position with the constructor. Character is going to hard code what surface it uses and, the sprite sequences. So we're going to keep it simple here. So initializing our character here, we're going to initialize the sprite. And that is going to be, well, I'll show you. The Pilgrim sprite only has running from left to right, right to left here. So it doesn't have up and down, doesn't have standing. So I got this sprite here. It's, it's a link sprite. It is 4 frames of animation plus a standing frame for all 4 directions. So we're going to use this. It's 90 by 90. So the file name is link9090.bmp. And the position is going to be the position that we pass in. And I believe that is it. Now we just have to initialize the animations. So what we can do is we can do a nice little for loop here. Int I is equal to 0 as long as I is less than, and we're going to convert to int sequences count I plus plus. So we're going to loop through all of the sequences. All right, so I guess I should have thought this through a little more, but the actual sequence is left, right, up, down, and I have up, down, left, right. So I just got to swap these around a little bit, the order. There we go. And now we can scan through these, scan through here. So what we're going to do, we're going to loop from 0 to standing left, basically 0 to 4, I believe. And for each of these, we're going to load in the walking sequences. So the walking sequences start here, and these guys are 90 by 90. So we want the X to start at basically 90 and the Y to start at 0. So we got 90, 0, the width is 90, the height is 90. The number of frames is 4. The surface is sprite. The hold time is going to be 0.16f, just guessing. Chroma, magenta, that's fine. So here is going to be the animation. Now, the start for the first time is going to be x of 90, y of 0, but the next one is going to be y 90. So we actually want 90 times I, and that will give us the starting position for each of these 4 animations. Now, we want to do the same thing, but for the standing sequences. So we're going to start at standing left, and we're going to run until count. Now, the x's are going to start at 0. Y is again going to be 90 times I. Frames, number of frames is going to be 1. Hold time doesn't really matter what we put in here. It is only a single frame. So this will push all of the animations in here, and their indexes will correspond to the indexes of these sequences. This is important because you're going to be using these names to refer to these animations at different times. So let's now implement these other functions. Draw is obviously going to be easy. We're just going to do GFX. No, we're going to do animations. Actually, that's a good point. We need to set the current animation. So we need to keep track of the current animation. So we're going to go sequences. I actually don't like the name sequences because the type isn't sequences. The type is a sequence. And these are the possible sequence values that you could have. So type name should be sequence. We'll fix that in here as well. There we go. Now we're going to go back to here. All right. So sequence, I current sequence. It's important to keep track of the current sequence that we have. And let's just set it initially to sequence standing down. All right, so when we draw, we're going to go animations at I current sequence dot draw. No, wait, we can't use the enumeration directly. We have to convert it to int first. So now we can get the index. We call draw. We pass in the position, which is at the position of the current character, and we pass in the graphics, GFX. And if we do that, thing's going to complain because it doesn't take vec2, it takes a v2. So what we can do for that is go into vec2, and we can create an operator here to convert to integer vector. So we'll include v2.h, and we will have operator v2 const, and this will allow us to convert to v2. And all we got to do there is just return int x, int y. So this will perform an implicit conversion. It will do it automatically for us. If we want it to not do it automatically, we can make this explicit, and that means that we have to explicitly state what we want to do. So now we can explicitly state, I want to convert this to v2, and the compiler will acquiesce. Update is again fairly straightforward. All you do is you go position plus an equal velocity times dt, and then you go animations at current sequence dot update dt. Update the current animation. Now, set direction is a tricky one. We're going to get a vector that indicates the direction of motion, and from that we want to, well, first off, we want to set our velocity. That's normal, but we also want to, from that, figure out what animation we should be playing. So for example, if dirx is greater than 0, we're going to be moving to the right. We're going to at least have a right component to our motion, and in that case we want the I current sequence equal to sequence walking right. Similarly, if we have motion to the left, then we want to do walking left. Else, if y is less than 0, we're going to be going up. If it's positive, we're going to be going down. Notice that this has dominance, so that if x is not 0, we're not going to check the y's. So the motion, the animation of this character is x dominant. If he has any x motion, you're not going to play an up or down animation. Else, if none of these are greater than or less than or 0, meaning if x and y are both 0, we must be standing still. So then we want to set the animation sequence to a standing still animation. And how we can do this is we can check our velocity, because our velocity tells us the last direction that we were moving in. So if velocity x is greater than 0, we set it to standing right. And we do the same there for all the other directions. Now, if velocity is also 0 and 0, that means that we were standing still in the previous frame. So just leave I current sequence the way it is. Leave it at the last direction. It's fine. Then in the end, we want to set our velocity equal to direction. Now direction, it could be the velocity we want the character to move at, or it could just be pure direction, like a unit vector. So if we assume it's pure direction, we need something to give our character speed. So let's go float speed, and we'll just set it equal to how many pixels per second? 80 pixels per second. I don't know, that's fine. So then what we do is velocity is equal to direction times speed, and this will scale the direction vector by the speed of the character. And there you go, you've got it all set up here. Now we just got to test the mother out. First, let's see if it builds. Well, at least it builds. Now we have to get this mother into the game. So in game.h, we include character.h, and now we are not going to have a surface and a animation. We're just going to have a character. Character link. And we'll set them off at 100, 100. Now what we want to do is in update model, we're going to set a vec2 direction, and we'll set it initially equal to 0.0f, 0.0f. Now we want to check our keyboard input. So if up is being pressed, we want to go dir.y minus and equals 1. So this will add a -1 to the y component. We're going to do the same for the other directions. So this gets our direction vector set up. You can normalize that if you like. I'm not going to bother with that. Then what we want to do is we want to go link dot, let me get rid of that bullshit there, link dot set direction dir, and then link dot update with the delta time. And finally in compose frame, we do link.draw with graphics, and that should be it. That should be our moving character. Is it going to work? Probably not. All right, so we've got a problem here. I already know what it is just by thinking. Source_rect.bottom less than source_rect.height. So our rectangles are bad, and they're going outside of our sprite. Why is this? Well, basically, if we go to character.cpp, you see we're using I to select positions in the vector, but here I starts from 0. Here I is starting from standing left. So we actually have to adjust I minus int sequence standing left, and that will account for the fact that we're not starting at 0 here, we're starting at standing left, which is 4, I believe. I mean, we could just use 4 and everything in here, wouldn't be a big deal. I just like to use these names because this is what these indices are going to be linked to, you know, down here. And we see that we succeeded. Let's run it. So far so good. We are not fucking up, and we are moving. I mean, left and right seem to be both moving in the same direction. That's probably a problem. We'll go to game.cpp and we'll see that they're both subtracting 1. So we will instead add 1. And now we can move to the right, we can move to the left, down, up. And yeah, we've got animation here. Probably bump the speed up a little bit here, and let's see if that looks a little better. Yeah, it's looking a little better. It's not the most amazing animation, 4 frames, but even 4 frames gets the job done here, as you can see. Not bad, not bad. And that's going to do it for this tutorial. There's one last thing I want to say here, and that is, oh Lord, please don't let me be misunderstood. This design that I've created here, I'm not trying to sell you on. I'm not trying to say this is optimal. This is the way I want you to do things. This is how a character, animated character should be made. No. This was just one asshole's idea of how it might be done. Something I just pulled out of my fucking ass. The point of this tutorial, the point of the game tutorials, isn't to show you this is how you do this. This is how you make an animated character. This is how you make the Snake game. No, these tutorials are about showing you how to take the building blocks and use them to solve problems. I'm giving you examples of problem solving here. The actual problem doesn't fucking matter. It could have been an animated sprite. It could have been a tile map. It could have been platformer physics. anything. The topic doesn't matter. What matters is I'm showing you the process of solving these problems. I'm giving you examples of it. Because let me tell you something, I'm not in this business here to create a bunch of monkey see, monkey do programmers who can only build things if they got a tutorial. What I do here is I give you the building blocks, I teach you the skills, and then I give you some examples of how you put those skills together to make shit. You know, people ask me all the time, when you're going to make a tutorial on making an RPG, when you're going to make one on making a platformer. I might make tutorials on that stuff. I may never make tutorials on that stuff. That's not the point. What I want to do is teach you the skills so that you don't need a fucking tutorial every time you want to make a different kind of game. You will have those creative building blocks and you will be able to put the shit together to make whatever the fuck you want. And more importantly, to make new shit that doesn't even exist yet and therefore has no tutorials. And I'm not saying that following tutorials like that is a terrible idea and you should never do it. It's great when you're starting out following that, going on the rails. You have a nice, safe, structured environment to get a feel for programming. But someday those fucking training wheels are going to have to come off. There isn't going to be any homework for today. I hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.